Hi guys, hi everybody. I'll just go knock my door. Sorry. So in this video, I want to talk through how to use the qmethod library in R to implement a Q factor analysis of a Q-sort data gathering procedure, which is a really cool way of allowing your participants in a study to express and construct their own opinion and attitudes, and not to need them to sort of conform to some of the theoretical assumptions of psychometric tests, primarily the idea that attitudes have to be consistent. So firstly, we're going to just go on and load the qmethod library, which has been really nicely and helpfully built. If you're not familiar with how to install a new library, look it up. But if you've not got it, you need to do it now and then call it. So now we've got qmethod. And I'm just going to do, there's various things you can do with the qmethod library. You can implement the whole study, so it can help generate various things that you need to do a qmethod study. What we're going to just do is we're going to simply look at the results of a Q study. So we'll use the data set that comes with it, which is called the lipset data set, and there's a study on the back of that which you could look at. Let's have a look at, so here you go, this is some of that data set. So what happens in a qmethod is you have a bunch of statements or items which are literally just statements about a thing. So it might be, if it was about the economy, it might be like taxes, good, or if it's about branding, it might be I like expensive brands. And then each participant is forced to put them into one of various ratings or categories, and you give the participants a forced distribution. So in this data set you can see it goes from -4 down to +4. So what we can do is, where's my enter button? Okay, so here we are. These are all the statements for this lipset data set. So what we can now do is we can create a, if I can find my cursor somewhere, there it is, an object which you can call anything. And all you have to do is call, I think, actually let's just see if we do it with data. No, wait a minute. Okay, sorry about that guys, I messed up and forgot the code, so I just had to go and look into documentation for the code. So what we're going to do here is we're going to call the qmethod function from the qmethod library, and then these are the parameters that we can set, and there's some other ones we can set depending on our data set, but this is just to get some results. So first we need to tell it the data, and this lipset data set we want the first bit of it, which is the Q sorts. We're going to suggest that there's 3 factors, and how many factors is, like with all factor analysis, a bit of a question of researcher judgment. So you could change this to 5 if you want, doesn't matter, but just 3 for the time being is useful. And then the type of factor rotation that you want. My colleague Tassos Pagliassis suggests that varimax rotation is probably not a very good one for qmethod, but it seems to be the default in this function, so let's just work with it. So when you run that, it gives you a summary to tell you that it's worked, and if there's any errors, it'll tell you those errors now. And then if we call results, we get loads and loads and loads of quantitative data, which is interesting because lots of the Q studies that we look at actually don't necessarily report all of this quantitative data, but what I'm going to do is just talk through my understanding of each section. So the first thing you get is the summary. Then you get the original data which has been used for the Q sort. So this is each statement, and then this is each participant with where they ranked it. So Q produces factors, and the factors are not derived from the items as in traditional sort of exploratory factor analysis, confirmatory factor analysis, but they are derived from the participants. So the factors comprise the participants, not the statements. So here we've said we think there's going to be 3 factors, and this is the factor loadings. So it tells us, let's go with factor 2. So factor 2 loads really heavily on US 1, US 2, and US 8. So if we presume, which I think is correct in the LipSec data set, that these participants come from different countries, we can see that factor 2 seems to represent something about America. There must be something about American culture which positions these 3 respondents in the same factor. So you can kind of run that as almost like a factor analysis on them, to cluster together or group together your participants. And then you need to do some interpretation to think, what is it about these participants that they have in common? The flagged Q sort is just a more interpretable representation of the factor loadings. So true means that this participant is flagged as being a member of that factor, and it puts people in one factor alone. So US 1 and 2, because we flagged them in factor 2, can't be in factor 1 or factor 3. Often people will then give these factors names in their final reporting. Next up we have the factor Z scores. So these are factor Z scores for the statements. So what this lets us now start to do is not to interpret the factors in terms of participants, but in terms of the attitudes or opinions that people in that factor tended to express. So the higher the Z score, the more associated with a factor a particular statement is. So here factor 1, statement 1 is a relatively large contributor to that factor. The factor scores are again a more interpretable way of making these Z scores, presenting the Z scores. So for each factor, it forces the statements into the same forced distribution that you gave to participants. So here we know that it's going to go from -4 to +4, and what you see at the end, if you wanted to, is for each factor you can put them into the forced distribution. So if you've told your participants at the start that they had to rate 2 things as +4 and 2 things as -4, you will see for each factor there'll be 2 +4s and 2 -4s. I should say for each of these, if you type results $, and then whatever it tells you here, you'll see the full data. So this is just a summary because there's actually more than 10 statements, so you need to write results $ZSC_N to see the full factor scores. So the factor Z scores and the factor scores are very similar. They come from the same information. They sort of represent the same thing, just in different ways. This is in Z scores, and then this is just forcing those Z scores into a distribution. I'm not 100% sure of the sort of formula through which they do that, but that's what it is. So often you'll see in papers these 2 things reported alongside each other for each statement. Sometimes you see people actually reproduce a Q-sort image for each of the factors as well. Okay. This just reports some general characteristics about the model. So it tells you the average relative coefficient. For some reason this is set to 0.8, and myself and my colleague Tassos Pagliassis have not been able to figure out why it doesn't seem to change no matter what the data or how many factors. So I'm not sure quite what that means. Anybody who knows would be more than welcome to tell me. N load is the number of participants or Q sorts that load onto the factor. So you see 3, 3, 3 here for factors 1, 2 and 3. If we go to the flags, that's referring to these 3 truths for each one. So it's not necessarily that it's equal, you can have different ones. The eigenvalues for each factor is just the eigenvalue for each factor, so that's a researcher judgment as to when you want to stop, when you think that the eigenvalues sort of go down on a hockey stick. Normally I think for factor analysis you say you need an eigenvalue of at least 1 to include a factor. The explained variance is the percentage of variance in the data that's explained through this factor, and obviously you can add those together to get a sum total of the variance, the cumulative variance that's explained by this model. And what you'll usually find is that as you add additional factors, the eigenvalues go down and the explained variance of the factor goes down. The reliability is the, I think, composite reliability. So this is as best as myself and Tassos could tell, is a measure of the reliability of the factor that comes from structural equation modelling, and it's slightly different from the reliability measures that are typically used in factor analysis, like Cronbach's alpha, which are measures of internal consistency for a factor. The composite reliability is more the reliability of the factor in relation to other factors. So I sort of need to understand this a bit more, to be honest, but that's what it is. And the standard error of the factor scores is the standard error of the factor scores, which are pretty standard. Then you've got the correlation between the factor Z scores, so it's literally what it says it is, factor Z scores and their correlations. Sometimes you'll see people also report the correlations, a correlation matrix between participants for each statement, or even for factor loadings. But Tassos and I couldn't really see the value in why you would do that particularly, because really all the Q factor analysis is kind of supposed to represent that, so you just get this huge table that's pretty unreadable. So you've got correlations between the factor Z scores, the standard error of differences between the factors, all kind of standard stuff. And then this is the thing which is often really interesting in factor analysis. So it signals whether a factor distinguishes, or whether a statement distinguishes one factor from others, whether it's a consensus or a statement which is true or present and ranked in the same place across factors. And it tells you whether any difference is statistically significant. So if we look at this for the full data set, because it's something which often people do report. Okay, that looks a bit ugly. Cool. What we'll see is, for a factor to distinguish all, for a statement to distinguish all factors, it will have to have a statistically significant distinguishing score for each factor. So it will have to distinguish factor 1 from factor 2, factor 1 from factor 3, and factor 2 from factor 3. If you had 5 factors, it would have to distinguish factor 1 from factor 2, factor 2 from factor 3, factor 3 from factor 4, factor 4 from factor 5, factor 1 from factor 3, and so on and so forth. So that to distinguish all. If it distinguishes only one factor, what that means is it doesn't distinguish factor 1 from factor 2, but it does distinguish factor 1 from factor 3, and factor 2 from factor 3. So you might also see that something distinguishes factor 1 and factor 2, or factor 1 and factor 3. And if something is consensus, it means that it is not statistically distinguished from any factors from any others. When you see something which hasn't got anything, it just means that it only distinguishes one factor from one other, but not from all others. So to distinguish it, it means factor 1. This statement distinguishes factor 1 from all other factors. This statement distinguishes factor 3 from all other factors. This factor distinguishes all the factors from each other. And what you can do is you can either represent this as a table, or even put it into the factor Q sorts and highlight which ones are significant at distinguishing statements. And that lets you see the statements and where they're positioned, where they're ranked, and which ones are important to drive your analysis. Because it could be that all of the distinguishing statements in a factor are negative. So there's something about the fact that one group of participants are distinguished from the others by their negative views, their negative evaluations of some statements, or that it could be that they're positive. It could be that they're in the middle, that people don't really feel very passionately about them in one factor or one group of participants, but in others they do. So that's all of the outputs of the Q method package talked through. Hopefully that makes some sense. Obviously you can't just dump this into a paper. You're going to need to actually do something with it, so you can just output it to Excel. I mean, if you really want to, you can just cut and paste it. Yeah, hopefully that's useful. Sorry this video's gone on too long. Yeah.